Hey guys, and welcome to this video. Uh, Today we're going to have something special. We're going to have a beginner-friendly tutorial where I'm going to show you guys how to build a neural network that can more or less recognize clothes like shirts, sneakers, bags, just by looking at different images. And you don't really need any prior experience with artificial intelligence, but the fundamentals within coding is kind of good to have. But at least if you watch the video, you will get a good grasp of how you can use coding and different kind of algorithms to build machine learning or neural networks. And I'm going to try to take it step by step so that you understand what I'm doing, and I'm going to try to explain everything along the way. But before we write any code, let's just take a minute to understand what a neural network is, because it can be a bit complex, right? It's not like linear regression or, yeah, it's a bit more complex than that. So basically, a neural network is kind of a way for a computer to learn from data, right? Sort of like if you think of our brain, how we learn from experience, right? So basically, I'm going to show the computer thousands of images of clothes, right? And I'm going to tell the computer, this is a shoe, this is a trouser, this is a high heel. I'm just going to tell it what it is, right? I'm going to send in a lot of images, and over time my model or my brain will learn patterns. For example, shoes usually have curved shapes, while pants maybe have two legs. And once it's trained, we can give it a new image it's never seen before, and it will make a smart guess. Kind of like, hey, that looks like a t-shirt because now I know the pattern of a t-shirt. So basically, that's what we're going to build today, and this is the end result. So basically, we're going to write a code, and then we're going to send in different kind of images, and it will predict what it is, and we have the true value what it actually is. So here you can see it predicted ankle boots, and it is actually an ankle boot, and this is a pullover, and pullover, trouser, trouser, etc. So this is what we're going to build today. So in order to do this, you're going to need a programmer ID. Like, I could use Visual Studio Code and I could use my computer, but since I'm going to feed in a lot of images and train this model a couple of times, my computer will be pretty choked up because I have a pretty shit computer. And well, if I'm streaming and if I'm recording and if I'm training a model, well, the computer is going to choke. So I'm going to use Google Colab, it's called, where you can use Google servers for training these kind of things, right? It's free of charge to begin with, and you can do quite some cool things, right? So basically, you have a code editor, and it has all the standard libraries that I need in order to do this. So you could use Visual Studio Code if you want. You could use Jupyter Notebook, but yeah, you're going to have to do some setup in order to do that. While using Google Colab, it's more or less plug and play. So the first thing we want to do is we want to import our packages. So we'll do import Tensorflow as TF, and then we'll import NumPy as NP, and then we'll do import matplotlib pyplot as PLT. And I can add some comments as well. Opa, uh, my bad. Let's do that. Step one, import packages, right? So I've imported the packages. So you can see that I have three packages. So TensorFlow is going to be the main library that I'm going to use to build and train the neural network. NumPy or NumPy will help us work with arrays of numbers like image data and other things. And Matplotlib is used to display the images on the screen. So basically, we can visualize the data we're having, which is pictures currently, right? So that's step one. We need to import all our packages, right? So I've done that. Now the second step is to load our data set, because again, without a data set, it's really hard to train a model, right? And you have a garbage data set, well, you get a garbage model. But we're lucky because we have this called Fashion MNIST, and then we'll do tf dot keras dot datasets dot fashion dot or underscore MNIST, like that. And then I will explain this very soon. And then we're just going to finish this code, and we'll do train underscore images, and then we'll do train underscore labels, and then we'll do what else will we'll do? Yeah, we'll do test underscore images, and we'll do test underscore labels equals to fashion MNIST and dot load underscore data. So this is the second step, right? So step two, step two, load data set. So what we're doing here is we're loading in a built-in dataset called Fashion MNIST, and this dataset has 70,000 grayscale images of clothing, and each one is 28 by 28 pixel. And what I'm doing is I'm taking this dataset and I'm splitting it into two parts. I'm splitting it into a training set and I'm splitting it into a test set. The training set is what the model will learn from, and the test set is what we will use to check how well it learned what we told it to learn, more or less. So that's basically it, right? Now this data set comes with different clothing things, right? So we have this is kind of an optional thing. You don't really have to define this, but I will do it anyway so that you see what type of clothing pictures is in this data set. So I'll do a class names equals to, and I'll do it like that. And we have t-shirt slash tops top, and then we'll have trouser, and then we have pull over, and then we have the dress, and we have a coat, and then we have sandal, and we have shirt, sneaker. We also have bags, and we have something called ankle boot. I think that's how you spell ankle, right? So that's the first thing we do. Basically, we create some class names because the labels in the data sets are numbers, and these numbers are from 0 to 9, right? 10. So this list will give a name to each number. For example, number 0 will be t-shirt top. Number 1 will be trouser. Number 2 will be pullover, and so on and so on. So basically, instead of working with numbers as names for these categories, we're giving these categories actual names, right? So it's much easier for you to actually visualize this, right? Now, the second step, we can actually, well, let's do this. Let's call this step three. Why not? Step three, and we'll call this class names, or define class names. And then step number four. Step four. So in step four, we'll do something. Oh my God, I always do this mistake. I accidentally press run, right? So let's just hide this for now. So in the step number four, we will do something called normalize the data. So we will normalize the images. So I'll write the code and I'll explain it afterwards, right? So we'll do train underscore images, and then we'll do test underscore images equals to train underscore images 255.0, and then we'll do the same with the test underscore images divided by 255 dot 0, like so. So the thing is, these images, these pixels range from 0 to 255. To help our neural network to learn faster and better, we will scale this number or their number, the pixels, down to a value between 0 and 1 by dividing it by 255. Because again, it will learn faster, it will train faster. It's just better to do it this way. This step is called normalize data. So I will also write it normalize the data or images, because we're working with images for now, right? Now the next step is to actually build the model. So we'll do step 5, build the model, right? Now this one is a bit more complex, but I'll write the code and then I'll explain it afterwards. So we'll start with defining our model variable, and then we'll do tf.keras, and then we'll do model, and then we'll do sequential, sequential. I think that's how you spell it, right? And then we'll do brackets like so, no, not test images, not now. And then we're going to have a bit, some different layers. So let's start with tf.keras dot layers, and then we'll do flatten, and then we'll do input underscore shape equals to, and then we'll do 28 by 28, like so. And then we'll go next line and we'll do tf.keras.layers.dense, and then we'll do 128. We'll start there. 128. Yeah, we'll start there. And then we'll do activation, and we'll call this one, we'll use relu. There we go. And then we'll do another layer, tf.keras.layers, and then we'll do dropout. Yeah, that's how you spell dropout. I was not sure. 0.2. And then we'll do the last layer, tf.keras.layers, layers, and then we'll do dense. And then we'll do 10, and we'll do activation, and we'll do here, let's use soft max. There we go. Okay, so uh, what we're doing here is we're building our neural network, right? And this neural network is made out of layer, and each layer will transform the data in some way, right? So, uh, okay, so let's try to break it down. So flatten. What flatten does, it will turn our 28 times 28 images into a flat list of 780, 60 numbers or so. And then we have this dense part, and this dense part is what it's saying is that this is a layer that has 128 neurons, right? And what these neurons will do is they will try to find patterns in the data. And we're using this relu as an activation function, which will add some non-linear linearities, more or less. Yeah, English is hard. Then we have the dropout. What dropout does is dropout will randomly turn off 20% of our neurons during the training to avoid overtraining or overfitting, right? And then we have this, the last layer that's dense. This is the final layer, and this will give us 10 number, each one for each clothing class. We have 10 classes, and we'll have 10 numbers here. And softmax will kind of make them act like probabilities, right? Again, if you find this interesting, you should, learn more about neural networks, machine learning, AI, etc., etc. So that's step number 5. So we've built the model. Now, step number 6 is we have to actually compile the model. So step 6, compile the model. Now here, we'll do model.compile, and then we'll do not equals to, and we'll do optimizer. Let's actually do like this because we're gonna need a couple of rows. We'll do we can just start here, optimizer, and we'll do optimizer. Let's do Adam again, and then we'll do a new row, and we can do loss. Loss will equals to what was it called, sparse underscore categorical, yeah, cross entropy. I think that's how you spell it. We'll notice if we did something wrong later on. And then we'll do metrics, and we'll do accuracy, like so. Now, what we've done here is this step is kind of telling the model how to learn. So Adam is an optimizer that will adjust the weights in this model in a smart way. This sentence that I cannot pronounce measures how wrong the predictions are, while accuracy is kind of the metric we care about. This this is how often the model gets it right. Basically, it found the right image, or it predicted the right name of this image. Is a boot, this is a shoe, whatever, right? So that's compile the model, step number 6. Now we have step number 7. step number se- opa. Step 7. In step 7, what we want to do is, why did I put these there? in step number 7, what we want to do is we want to train the model. So we haven't trained the model yet. We just kind of given it the blueprints of how it should be trained. Here we actually train the model, right? And what we do here is we do model.fit, and then we do train underscore images, and then we do train underscore labels, and then we do epochs. Epochs, how do you spell epochs? Epochs, like so. 5. We'll start with 5. So what this step does, this is kind of where the magic happens, right? So we trained the model by letting it look at 60,000, all of the 60,000 training images. And this epoch, what it does, it will show this neural network these 60,000 images 5 times, right? And what it does, it tries to improve each time. So first we show it 60,000 images, it learns. And then we show it again, and it tries to be better and better and better and better. And you can increase this number, but we're going to talk about that a bit later. But this is basically the step to train the model, right? Now, the next step is kind of to evaluate the model. So now we've trained the model. Now, how good is the model, right? So we have to evaluate what we've done. So step 8, evaluate model, evaluate the model, like so. Now, in order to evaluate the model, we'll write this code, test underscore loss. So we'll create a new variable, and test underscore accuracy. And then we'll do model dot evaluate. Yeah, I think it's evaluate small e, but maybe I'm wrong. Test underscore images, and then we'll do test underscore labels, and then we'll do verbose equals to 2, like so. And then we can do a print because we want to see what the score is, right? So we'll do like that, and we'll do a backslash. We'll do a backslash, and we'll do test accuracy, and then we'll do test underscore accuracy, like so. So what this code does is after the training, we will evaluate the model, but this time we will use the test data. This test data contains images the model has never seen before, right? It doesn't, these images are not included in the training set, so it has never seen these images, right? And what this does, it will give us an honest score of how well this actually performs. And depending on how well it performs, we will need to adjust different things in order to increase our accuracy. But again, let's do one loop, and then we'll talk about it again, right? Now, the next step, step 9, is to make predictions. And this is the last step, right? So we've trained the model, and now we actually want to try it out. We want to see the result. How well did it do? So we want to send in the images. We want to see what image we sent, and we want to see what the result of this was. So step 9, step 8, actually, step 8. No, step 9, because a valid model is step 9. Step 8. So step 8 or step 9, sorry guys, sorry. We will do predictions, right? So predictions equals to model.predict, and then we'll do test underscore images. So basically what we do is here, what this does is we kind of ask the model to make predictions on all the test images, right? And each prediction is a list of 10 numbers, one for each class, and it will represent the confidence for each category, right? How confident are you about this, right? And then step 10 is let's display the results. Step 10, display result. Can, step 9, make predictions. So let's display the results because again, I did the same mistake. There we go. So step 10, display the result. And in order to display this result, we need to write some code, right? And we're going to, yeah, let's write the code first. So plt.figure, and then we'll do fig size equals to, let's do 12 by 6. And then we'll do a for loop for e in range. Let's do 20 images maybe. And we'll do subplot, yeah, subplot. And in the subplot, we'll do, because we have 20, we'll do 4 by 5. And then we'll do I plus 1 to increment it, right? So on the next line, we want to do plt.im show. We want to see it test underscore images and then at index, and then we'll do cmap plt dot cm dot binary, and then we'll do what do we do? Yeah, the labels predicted underscore label equals to class underscore names. So we have the class names, right? And then we'll do test underscore labels at I, like so. And then, so that's the predicted label. And then we actually need the true result, right? So we'll do true underscore label because we want to see if we were correct or not. So true underscore label, class names, and then we'll do test underscore labels, like so. I think that's no. I did something wrong here. So this should not be like this. So class names should be np dot predicted label class name np dot. It should be arg max, and then predictions at I. Yeah, this is correct, I think. And here we have to finish this, so this will be at I. There we go. So we have the true label and we have the predicted label. Now we need the title, and we'll do F, and we'll do quotes, and we'll do pred for prediction, right? And then we'll just do chicken wings or chicken lips or whatever you call this predicted label, like so. And then we'll do a backslash n, and then we'll do true for the correct answer, and then we'll do true underscore label. Yeah, there we go. And then we can actually also add we don't need it, but let's add a font size in order for us to actually see what we're doing, because it might be super duper small. And then we'll do plt.axis, and we'll do off for here. And then we can do plt.tight. Is that how you spell? No, tight. That's how you spell tight, right? Layout, and then we'll do like that, and then plt.show, like so. Yeah, I think that's that. So basically, what we've done here is we are visualizing 20 test images. Each one will show the model's prediction and the correct answer. And this is a great way to spot errors and understand what the model is doing right or wrong, right? So probably something is wrong. Yeah, we have something wrong here. I did something wrong here. What did I do on this one? Why is that wrong? So we have train images, train labels, yeah, and then we have test images. Fashion.mnist.load data. Let's just press play for now and let's see what happens. Okay, so that was correct, I suppose. It was not wrong. We have an error somewhere. We have an error here. It says, what does it says? Our error says something wrong with this. Maybe I spelled sequential wrong. So maybe it should be. I did ctf.keras models. Maybe that's good enough. Let's try it out. So now we can see that it started. So it seems like everything is working. So now epoch number 1 is going. So we feeding it the images, it's training, and you see we have an accuracy of 76%, 76%, right? So it's not that accurate yet. But you see on epoch number 2, it immediately rose to 85%. And then the increment is not that high, so 85, 86. Can we get an 88? Can we get a 90 maybe even? 87. And you see, this is the power of Google Colab. Um, we don't really need a strong computer because, yeah, we have Google's computers, Google's servers, right? We have another wrong on line 34. Here, what's wrong here? Test loss, test accuracy equals to model dot evaluate test images, test labels, verbose. Let me just see. Test labels. It's labels. Test lay test underscore labels. Right, so right? Yeah. Boom. And we go again. So what you can do is you can actually run the code a couple of times while you're writing the code, so you don't end up as with many errors in the end as I do. But yeah, that's kind of my style. Cowboy coding, shotgun debugging. So we fix the problem as they show up. Okay, so test, there we go. Test accuracy is 86%. And so here's the 20 images that we're displaying, and then we can see, so this one, we predicted it was an ankle boot, and it was an ankle boot. Pullover, pullover, trouser, 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 shirt, shirt, trouser, trouser, coat, coat, shirt, shirt, sandal, sandal, sneaker, sneaker, coat, coat, sandal, sandal. Here we go. Here we have an error, a wrong, right? So we predicted that this is a bag, but it's actually a sneaker. I don't know how we could turn this into a bag, how we predicted it's a bag, but yeah, it's not a bag. But so this is one wrong. Dress, dress, coat, coat, trouser, trouser, pullover, pullover. Here we have another issue. You see, we predicted a pullover, but this is actually a coat. And then we have bag, bag, t-shirt, t-shirt. So basically, out of 20 uh, that we displayed, two were wrong. Basically, we have 86%. We can see here that accuracy is 86%. So it's not 100%, right? And it's kind of hard to get it at 100%. This is actually a really good start to get it at 86%, and I'm quite happy with that. Now, what you can do, let's say, and this is actually a good exercise for you guys, right? So if you already know machine learning and are familiar with these kind of things, what you can do is try to increase the accuracy here, and you can increase the accuracy in different ways, right? For example, instead of 128 nodes, we can maybe use 256. Maybe we'll add another layer here, right? We can also increase the epochs to 10 or 20 or 50. For example, you see that we have 5 right now, and we have 86%, 87.8763, right? So let's just change this to 10 before I end the video, just to show you guys that. So we have 87, what did I say? 8763, 8763. So let's just start with and changing this to 10, right? So instead of doing this 5 times, we'll do it 10 times. So 8763, 8763, 8763. The goal is to get above that. 8763. Let's see how it goes. Well, you do 10, it takes, twice as long because we went from 5 to 10, but doesn't really matter. You see? So what did we have? 8763. So we're already above it, right? So now we're at 88%, and we still have 3 epochs to go. So hopefully we'll achieve 90. I don't think we'll achieve 90%, maybe 89. We'll see. It doesn't really matter what we achieve here. The thing is, you can see that our accuracy actually increased, right? So there are different things you can do to try to increase your accuracy, and this is kind of, the gist of it, right? To adjust where needed. But in order for you to actually evaluate the results in a good manner, you have to be careful. Don't change too much at the same time, right? You change one thing, you run it again. You change another thing, you run it again, and you run it and you change until you're satisfied. As long as the results go up, then you're doing something right. And you see that we went from 87 something something to 89%, which is much better, much better. It's 2% better than what we had before. And again, we did some minimal changes to the code. Again, we could add different things. We could use another layer. We could change this to 256 nodes instead. There are different things we can do. But yeah, that's kind of it, guys. You've successfully kind of built an image classifier, right? Uh, well, you've done more than that, to be honest. Basically, with this video and this code, if you wrote this code, you've kind of built your first neural network, if this is your first. And what it did, it this neural network looked at 1,000 images, it learned to spot patterns, and now it can recognize clothes all by itself. This is the same kind of technique used in the real world AI, like image search, self-driving cars, and even when you try to use medical diagnosis, for example, right? And if you like this video, because this is my first time doing a video within machine learning and AI, if you like it, put a thumbs up, and maybe I'll do more videos in this category. So this is a kind of a pilot, and yeah, don't forget to subscribe, guys. Don't forget to subscribe. Anyways, thank you very much, guys, and yeah, have a good day. Bye bye.